Welcome to All This Math. This is Professor Parker, and today we're going to do some what I call nursing school math. All right, nursing school math. All right, so we have a word problem, right, that you might see in a math course that is meant to prepare you for nursing school, whether you have yet to enter a nursing program or whether you're already in a nursing program. All right, so let's take a look at this for a moment. It looks like a lot, but let's read it. Try to understand the information within it, and then pull out the important information, create some equations that we can then solve, and finally answer the question that's being asked in this word problem. So, the problem says a 2,000 milliliter vial of medication is to be used for 2 patients. All right, 2 patients. Sabira is to get 300 milliliters more than Hanifa, and 100 milliliters will be left in the vial. How much medication will be administered to Sabira? All right. Now, there is a specific way to approach this type of problem. But if you have never seen this type of problem, and if you have never been taught how to do this type of problem, you may have absolutely no idea how to figure this out. All right? Don't feel bad, right? I know how to do this because I've been taught how to do this, okay? So if you were never taught how to do this, don't feel bad if you don't know how to do it. A lot of people get discouraged about mathematics because we have this expectation that you're supposed to be able to just look at a random word problem and just know how to do it. And if you don't automatically know how to do it, just from looking at it, you feel like, oh, see, I'm not good at math. No, it's not that you're not good at math. It's that you just weren't taught how to do this particular type of problem. So I'm going to do my best in this video to try to teach you how to do this particular type of problem. All right. So first, because it's a word problem, let's pull out some key information. All right, some key information, some key elements. So 2,000 milliliters, that's important. So I'm going to underline that because that's going to be important. All right, 2 patients. That's important. All right, Sabira is going to get 300 milliliters more than, that's going to be important when we set up our equations. And this part right here, this 100 milliliters part will be left in the vial. That's going to be important. And how much medication will be administered to Sabira? All right, so basically, because when we see a question like this, and I'm trying to think of the best way to describe this, but when we see a question like this, we have to set up a system of equations. Now, what I'm trying to do is figure out what's the best way to let you know that it will be a system of equations. All right. The way that you'll know it's going to be a system of equations, meaning 2 equations with where each equation has 2 variables in it, right? And you're going to solve for both variables. The best way for you to know that is because we're dealing with 2 elements, okay? 2 elements. We have 2 patients, all right? And the problem also tells us about the relationship between these 2 patients in 2 different ways, all right? So we first want to pick variables to represent our 2 patients. First patient is Sabira. Second patient is Hanifa. So what I'm going to do is I'm going to create variables for them. I'm not going to use variable S to represent Sabira because my S's sometimes look like 5s, and I don't want to confuse nobody. So I'm going to use a B to represent Sabira, right? Just in case. I don't know, her nickname might be Booby or something. Who knows? All right. So I'm going to say let B equal Sabira's meds. And then for Hanifa, I'm going to say let H equal Hanifa's meds. All right? So you got to pick out your variables that you're going to use before you then create your equations. And then once you create have your variables, you then are going to create your equations. And then once you create your equations, you're going to solve your equations, and then you're going to be done. All right, so what information do I have? And when you deal with word problems like this, you're going to find yourself reading the word problem over and over and over again. You might read it like 5 or 6 times. There's nothing wrong with that. That's par for the course. That is normal. So I go back to the first sentence. A 2,000 milliliter vial of medication is to be used for 2 patients. So remember I said we got 2 patients and we got 2 pieces of information that's related to the 2 patients or the 2 elements in this particular problem. So I know that if they're going to have there's a 2,000 milliliter vial of medication. It's going to be used on the two patients. Who are the two patients? Letter B and letter H. All right. So I know one of my equations is going to be this. B plus H, the amount of Sabira's medication plus the amount of Hanifa's medication, is going to equal a 2,000 milliliter vial. So I think. Reading is fundamental, right? I would tell students all the time, you got to read first, then do math, right? If I keep reading this problem, I read the second sentence. Sabira is to get 300 milliliters more than Hanifa, and 100 milliliters will be left in the vial. Now, let's jump to this part right here. And 100 milliliters will be left in the vial. All right? We're going to deal with this part later in a moment, real quick. But 100 milliliters is going to be left in the vial. It starts out talking about a 2,000 milliliter vial of medicine, though, right? So they trying to be crafty. They're trying to trick us, right? So you're not using the whole 2,000. That's what that basically means. If you're going to have 100 milliliters left in the vial, you're not using the whole 2,000. So you're only using most of it. You're not using all of it. So if you're going to have 100 milliliters left in the vial, and the vial originally had 2,000 milliliters, that means you're only using what? 1,900. So we're going to erase that 2,000, and we're going to put 1,900. Because we're going to administer 1,900 milliliters. We're actually administering only 1,900 milliliters. So we got B plus H equals 1,900. That's our first equation. All right? Now remember, this is a system of equations, because in this problem, we have two elements that we're dealing with. The elements being the two patients, right? And different pieces of information that is related to them, two different types of information that's related to the two elements. Read this part. Sabira is to get 300 milliliters more than Hanifa. So dig this. Just this part right here is going to be our second equation. All right? Now, people say all the time, math is like another language. That's why it's so confusing. I don't get it's like another language. And when they say that, they're absolutely right. Math is like another language. So what we have to do is we have to translate this clause in this sentence into an equation. Sabira is to get 300 milliliters more than Hanifa. All right. So what variable do I use to represent Sabira? B. So I write B. Is to get. Is to get. That's a predicate or an action. It's has an action verb in it. Is to get. Right? That's my equal sign. All right? So this is B. This is my equal sign. 300 milliliters more than. More than means addition. All right? 300 plus Hanifa. However much Hanifa gets. So we got 300 plus Hanifa is represented by the lowercase letter h. Boom. And now I got my system of equations, and I got my two equations that I'm going to use to solve for B and for H. But really, I only need to solve for B because the main question is how much medication will be administered to Sabira. How much, right? How much will be administered to her? Okay. So what happens is, but I got to find Hanifa's too, because I want to solve the whole system so that I can check my work. Because I don't want to just answer how much medication Sabira gets, because then I have no way of checking to see if I did it correctly. So I got to answer both in order to be able to check my work, because that's key when we're doing algebra. All right. So, but let me just back up and let me just go over this again. Sabira is to get 300 milliliters more than Hanifa. All right. So I represent Sabira with the letter B right there. Is to get equal sign. 300 milliliters, 300, more than Hanifa. So basically, however much Hanifa got, we add 300 to it. Now, it doesn't matter. If you feel more comfortable, you could have wrote H plus 300. 300 plus H is the same thing as H plus 300, because addition is commutative, right? That's the words you might have learned in an algebra class in the past. Commutative property, just like 3 plus 2 equals 5. 2 plus 3 equals 5. The order doesn't matter when you're doing addition, okay? So 300 more than Hanifa is 300 plus H. Now, this is a system of equations. I want to solve for B and I want to solve for H. Now, I'm going to use a method that's called substitution. Substitution is when you take the value of one of the variables and you take that and you substitute it into the other equation in place of that variable, right? Or you plug it in the other equation in the place of that variable. So what it looks like is this. I already know that B is equal to this expression, 300 plus H, right? I know that. Also know that there's a B in this equation. I need to substitute. But before I substitute, let me tell you why I need to substitute. I need to substitute because I can't solve for either one of these in one equation. You can't, if you ever have an equation that's got 2 different variables in it or 3 different variables in it, in that one equation, you can't solve for none of them. You can only solve for one variable in one equation. And in this equation, we have 2 different variables, right? Now, I could have H written out 3 different times in one equation, and I can solve for H by combining like terms. But I can't have 2 different variables or 3 different variables or 4 or 5 different variables in one equation and expect to be able to solve for any one of those variables. You just can't do that, right? You can find expressions that they're equal to, but right now we're getting to the point where we're trying to find an actual number, a tangible number, right? We're trying to find the actual amount of medication, right? An actual number. So what I'm going to do is I'm going to replace this B with this expression right here. And this is what it's going to look like. So this B gets replaced. Everything else in the equation stays the same. Everything else stays the same. This plus sign still going to be there. This H still going to be there. The equal sign still going to be there. The 1900 still going to be there. But everything else stays the same except for this B. This B gets replaced with 300 plus H. Now watch what I do. 300 plus H plus H equals 1900, right? That's my new equation. And now with this equation, I can solve for H, right? And it doesn't matter. I mean, ultimately, I want to solve for B, but I'm going to find H first, and then I'm going to go back and find B because I know that B is equal to 300 plus whatever H is. All right? So watch this. Now, I see 2 like terms. I see H and H. So I'm going to combine like terms. So that's going to give me 300 plus 2H is equal to 1900. All right? We're getting closer. Now, my goal is first to isolate 2H. I'm going to isolate 2H by itself, right? So I got to get rid of 300. The way you get rid of a positive 300 is you apply the opposite, which is a negative 300. The action is to subtract. That's how you apply a negative. So I do minus 300 on the left. I do minus 300 on the right. Because in equations, we got to stay balanced. If I do it on the left, I got to do it on the right. Then the 2H comes down. 1900 minus 300 is 1600. Now I got 2H isolated. Now from there, I'm going to isolate H. So if I want to isolate H, I got to get rid of this 2. So I got to do the opposite operation. I don't subtract 2. I don't multiply by 2. I don't add 2. I do the opposite of multiplication because 2H means 2 times H, right? 2 times H, that's multiplication. The opposite of that is division. So I'm going to do this. Divide by 2 on the left side. Divide by 2 on the right side. 2 divided by 2 gives me 1 and 1, which gives me H. 1600 divided by 2 is going to give me 800. All right? So I solve for H. I think it's 800. I think that Hanifa is going to be administered 800 milliliters out of that 1900 from the vial, right? Remember, the whole vial was 2000, but 100 milliliters is going to be left in the vial, all right? So out of that 1900, Hanifa's getting 800 of it, right? So now I'm going to go here, and I'm going to solve for B. I'm going to answer the main question, which is how much medication will be administered to Sabira? So we got B equals 300 plus 800. And we know how to add, so we know 300 plus 800, just like it was money, that's 1100. Now, because I know how much Sabira is being administered, and I know how much Hanifa is being administered, now I can go back and check my work and make sure that it's correct, right? If we go back to the original problem, it says that, let me see, 2 patients, 2,000 milliliter vial, 100 milliliters will be left in the vial. So you immediately subtract the 100 from the 2,000, you get 1,900. So these 2 amounts should add up to 1,900. 1,100 milliliters plus 800 milliliters. They, in fact, do add up to 1,900. But we're not done yet. It works for the first equation, but we have to make sure it works for the second equation. And we kind of already know what it's going to because we just used the second equation to get that number, right? But let's just be sure. So Sabira is to get 300 milliliters more than Hanifa. Is 1,100 300 more than 800? It is. So this is how much she's going to get administered out of that 2,000 milliliter vial, which will have 100 milliliters left inside of it. Like I said, I like doing this type of math. Well, I like doing all type of math. Some more than others, but for the most part, I like doing all type of math. But this is what I'm going to start doing, more videos like this. Nursing school math. Nursing school math. Because a lot of people would definitely be excellent healthcare professionals, would definitely be excellent registered nurses, but it's the math. The math just blocks them. It serves as an obstruction, and then they can't really, advance in the coursework. And, I'm trying to do something about that, right? So I'm going to start producing more of these type of videos so that people will be able to understand the math that they're not understanding, wherever they are, whatever school they are, whatever program they're in, just to try to help the cause and help the people. You know what I'm saying? So, as usual, please like the video if you liked it. Share the video. Subscribe to the page if you haven't already. Send this video out to somebody that's in nursing school, somebody that's about to go to nursing school, somebody that has interest in going to nursing school. Just, let some people know, let them know what we're doing over here at All This Math. All right? And as always, do remember that there's all this math all around you. Peace.